Today, we have the opportunity to listen to a really interesting piece of work done by Dr. Hayden Wilson, who sits within the data science team at uLwazi. Hayden is going to be talking about an operational information management system that was developed for the shallow marine and coastal research infrastructure. Hayden has been with the uLwazi node, I think, since the beginning, so he has been with SAEON for a long time. His work has kind of bounced him onto a few different things, as well as his PhD in a sort of a very different field. But he really specializes in the development of data products within our team for things like the South African Risk and Vulnerability Atlas, the Bioenergy Atlas, and now moving and focusing more on developing tools and products for the research infrastructures at SAEON. There is space at the end for a Q&A session, but in the meantime, you're welcome to pop any questions or thoughts that come to your mind in the chat, and then we can address them at the end. So over to you, Hayden.
Cool. Morning all, and thank you so much for coming to listen to me chat to you today. Yeah, not just in the chat. If anyone wants to pipe up and ask me a quick burning question, you're more than welcome to interrupt me. So basically today's presentation, it's going to be a little bit death by PowerPoint to start off with. So sorry about that. I've tried to make it at least slightly interesting. And then what we're going to go in is kind of get into the nuts and bolts of the system that I've built. And yeah, then what I think might be quite nice is for us to try and at the end of the chat, kind of brainstorm a little bit about potential other applications for the technology that I'm showcasing today. So if you guys can keep that in mind while I'm busy presenting, I'd really appreciate it. Cool. So yeah, I'm going to turn off my screen because I think that my fragile internet connection needs every little bit of bandwidth that it can get. So yeah, let's get started. Let me know when you can see my screen.
It's coming through. There we go. You can see it on our side.
Cool. All right. So developing mobile data systems for the collection of scientific and operational information. So basically what the problem that we've got is that here at SAEON, because we're expanding our capacity constantly, we're deploying new instruments, we're acquiring new vehicles and vessels, there's communication equipment that's getting put out, and then there are various types of routine data collection, processes that the technicians need to perform. This sort of stuff is increasing more and more and more over time. And what basically happens is that different types of equipment have their own specific requirements that need to be satisfied for that equipment to remain in service. So for instance, you need to keep track of things like consumables. Do you have enough reagents? Are we running low on rope? But then you've also got things like different instruments have got their own servicing intervals, their licensing intervals. They might need to go into labs in order to be calibrated and certified. And then different types of instruments and equipment have their own deployment procedures. And within the context of SMCRI, this is particularly important because getting to the equipment is a difficult process for them. They've got to go out in boats, and quite often this is dependent on the weather, what the available weather's doing. So logistically, it's tricky, and the fleet of instruments that they've got out in the water is increasing rapidly. So a bit of history to this. Last science meeting, we invited the different nodes to kind of talk to us and talk about, what sorts of ways could the uLwazi node provide the rest of SAEON with assistance. And Sean Basel mentioned that they were interested, that they had this problem and that they were looking for a technology solution that could assist them with addressing their operational logistics. So maintaining the logs of the operational information that they've got is cumbersome and potentially error prone. The biggest problem that they've got is that at present they're using a spreadsheet-based system. And I just had a quick look, and in their old system, just one of the metadata sheets that they've got has got 69 tabs in a single document. And even the spreadsheets within that are still very complicated, with complicated formulas that need to be shifted across. And while they've done an excellent job so far, it's very time consuming for them to be able to work like that. And it requires a lot of manual maintenance and inputs from the technicians, which they're battling to get to when they've still got complicated physical activities that they need to perform, as well as additional research in the form of biodiversity surveys and so on. So it means that they've got a high admin workload. And the biggest problem that I think is that this kind of operational metadata that they harvest is basically decoupled from the day-to-day activities of the technicians. So, they know that they've got to go and fill in all of these logs and forms and so on, and you can see why it's important. But it's kind of something that is a drag that you need to do at the end of the day, and doesn't really affect what you're doing, what you're doing in terms of planning and so on, because they know what's coming. And so the bottom line is that the pool of sites and instruments and equipment that needs to be monitored and maintained is actually increasing faster than the pool of available technicians at SMCRI. So the idea was to try and find some way of improving their operational efficiency and reducing their workload. So my thought around this thing is to try and automate the boring stuff and leave more time for fun things. And that was basically my slogan through this whole thing. And the way that I achieved that was that I had a little personal mantra, which was, the thing has to be useful. It has to be automated, and it has to be robust, and it has to be dynamic. And if you look at this, what does that actually mean? So when I thought about building this, I thought, okay, what we should probably do is we should have some sort of mobile data collection system where technicians will be able to collect different types of operational data, and then we should put that into a database of some sort. And then, from that database, what we'll be able to do is present them with various data summaries of some sort, maybe dashboards or automated reports or something like that. I thought, okay, well, that seems simple enough. Let's go. And then through various engagements with the technicians, I started to realize that this actually became quite a bit more complicated. So what we thought of is that the way that the SMCRI technicians kind of think about maintaining and operating all of the equipment that they've got, and also the different research sites that they've got, is that it's almost like an object-based system. So, an object could be a mooring, which has got different types of instruments deployed to it, but an object could also be a vessel, which has got different certification procedures, and it's got its own things going on. And then, an object could be the radio that's on board those different vessels. And so there are different things that need to be managed within an operational information management system. And different classes of objects will have their own rule sets associated with them. However, there are cases where there are commonalities between these different classes of objects. And then what there is there are also hierarchies. So different object classes will have categories and subcategories. And we needed to be able to accommodate that. And then what I also realized is that because of the fact that, there's research is a dynamic process, which means that, there's certain sites that come online, there's certain instruments that go down. You need to be able to accommodate for that type of flexibility. But you need to be able to keep track of this stuff. And so what I realized is that unique identifiers for the different classes of objects need to be generated procedurally and maintained through the entire system. And then linked to that is the thought that database objects need to be added dynamically, and mobile applications need to be responsive to those changes. So, for instance, if one technician is working on a particular mooring and he adds some new things to the system, then those changes need to be reflected in the way that the other technicians can interact with their applications. But then what's really important is if those sorts of changes can happen, you need to maintain histories of what types of things have happened within the system. So that includes, notes and comments and so on that get collected along the way. And so with a lot of interaction with MT from SMCRI, we developed this kind of tag-based management system, which we use to determine the types of relationships that exist between different classes of objects. So that's a mouthful. So let's get into the nuts and bolts of this whole thing. So the first component that we started working on was the mobile field collection application. And we had a look at a couple of different options available out there, and we settled on using ESRI's Survey 123. Another strong competitor was ODK Collect. As a matter of fact, they're almost identical. But I liked using Survey 123 just because it is easier for us to integrate data outputs from Survey 123 into dashboards. Whereas if we'd gone down the ODK Collect route, I would have had to develop dashboards using a Dash application in Python, which would have been a bit more time consuming. So the advantages for using Survey 123 is that it's very easily customizable. It uses a technology called XForrm in order to basically convert Excel spreadsheets into mobile applications. So it's really simple for people to work with and interact with. It's compatible with iOS, Android, and Windows. It's offline capable, which means that if the device that you're using to capture operational information doesn't have internet connectivity, then what will happen is that data will just get stored on the device until the device gets internet connectivity again, and the user basically says, okay, I want to upload this to the cloud. So its offline capabilities are very good with this application. And yeah, there's a strong user base behind it, so you can get a lot of helpful feedback from it. So the next component that we used was ArcGIS Online. The reason why we went with ArcGIS Online is because it's a very robust cloud-hosted data service, and it talks well to Survey 123. And what it also provides us with is application hosting. So if we want to run anything like a dashboard or web apps or something like that, it's very easy to develop those in ArcGIS Online. And it also provides us with user access control. So the various dashboards and applications and so on that get developed as part of SMCRI, we can control which people have what sort of roles within the system. So for instance, I would be an administrator, but then if later on the line, if we want to upload a junior technician, we might give them the role of just being a data provider. So they would be able to upload data, but they wouldn't be able to change the surveys, for instance. And then what it also provides us with is versioning, which is something that doesn't exist in the previous Excel spreadsheet-based system where changes are changes, and unless you've got made physical copies of your spreadsheet, it's very difficult to do manual version control like that. And finally, what it does is it provides us with data analysis in the cloud. The next component that we used are ESRI Dashboards. So ESRI Dashboards provide us with mapping and charting abilities, as well as interactive data exploration and filtering, and so on. And then the final component is the Python scripts. So basically, Python is the grease that keeps this whole machine moving. I've developed several Python scripts which are useful for which are used basically to read stuff from where the data is hosted on ArcGIS Online and perform various data analysis tasks, data transformations, and so on, and then upload that data to the different application data tables, so that when one technician makes a change, then those changes are reflected in all of the other technicians' applications. So yeah, all of the Python scripts at present run on one of SAEON's surveys. So the basic shape of this thing was that we've got survey 123 that talks to ArcGIS Online. Python scripts then pull data from ArcGIS Online to our SAEON servers where things happen to it. And then Python pulls stuff from the servers and pushes it back to ArcGIS Online, where it can be shown in dashboards, or it can be shown inside the Survey 123 apps. So demo time, hooray, enough death by PowerPoint. So what I'm going to start showing you guys is a little bit about how easy it is to use do survey design with XForrm, and then I'm going to go into a little bit of functionality and some of the things that we've implemented. And then I'm going to go very briefly into Python, and then I'll spend a bit more time on what the different dashboards are doing. So let me exit that. Okay, which one am I looking for? That one. Okay, so this is the kind of development environment that we use for building the different applications. So this over here, that window is kind of a view of what the final app would look like. And then up here is the way that the survey is designed. And basically the way that it works is that each survey type, each survey question that you're asking inside the survey is a row inside an Excel spreadsheet. So for instance, if you have a look here, we've got the first thing is a select one type question, and then it's saying selected from a list called CMP types. So if you go over to the choices tab, you'll see that I've got a list here saying CMP type, and then these are the things that you can choose from there. And it's quite powerful because what you can do is, there are lots of different types of questions and things that you can get your users to do inside the system. So we've got options such as select from a list or select multiple from a list. We've got text inputs, we've got integer inputs, we've got date time inputs. More fancy functionality includes stuff like, if we wanted to, you can get your users to collect geo points, or if they want to use the camera on the mobile device, then they can capture an image, record audio. You can scan barcodes. There's a lot of stuff that you can do and incorporate inside your surveys. And basically what happens is that every time you save your Excel spreadsheet, those changes are reflected inside the application that you're developing. So if I just insert a thing here, and I'm going to add some text, and the thing is going to be called example, and we've got example. If I push save now, what we should see is that we've now added a text input at the start of the survey, where people can add some text. So now there we go. We've got our thing called example, and you can add additional things such as hints and guidance, and you can change the appearance, which is the way that these things are displayed. You can define whether or not these things are required fields, and messages. So there's a lot of, oh yeah, and you can do calculations on the data that gets added. So there's a lot of stuff that you can do inside XForrm. And so I really think that, if you can think of a use case where you've got a case of doing the same thing on repeated occasions, but at different locations, or even the same location at different times, and you want to be able to pull the data that you worked with previously, then doing something like developing your surveys using ODK Collect, XForrm, or ESRI Survey 123, I'd really suggest doing that, because it'll just save you so much time in the long run. So having designed these mobile surveys, what happens is after it's designed, it'll just be sitting on your laptop or your desktop or whatever you've built it on. And it's only through the act of publishing it that it then gets added to, or packaged up in a way that it's accessible to other people. And at present, that's dealt with entirely through SAEON's ArcGIS Online system. However, what you can also do is you can provide people with a link to the survey, and they can, and if you've made that survey publicly available, then accessing the link will enable people to download and interact with that survey and upload data. So I think this thing has got extreme potential for citizen science applications. So, if we wanted people to collect meteorology, met readings of different types, or perform biodiversity surveys or something like that, I think it could be quite helpful. So that's it for survey design. And now what I'm going to go through is the way that you can the different ways that I thought that we could interact with the system that I've developed. So this is the view that that someone that would be collecting data gets on their cell phone or whichever device they're using to collect data. So there are two main things, which is there's the collection thing, which gives you access to the form. And then there's what we call the outbox, which is where you can access all of the previous forms that you submitted. So you can open these things and interact with them if you want to. But I'm going to go through with the actual collection process. So if by clicking collect, our technicians are first provided with an example of a pre-deployment workflow, and they need to just select what type of instrument are they working on. So I'm going to select gully temperature probes, and then if they so they're going to be deploying these instruments to somewhere, so they need to select a site that they are deploying it to. And then if they select new satellite site, then they get prompted to add that type of additional supplementary information around where this satellite site actually is. But for now, I'm just going to keep it at, we're going to be deploying this thing to Algoa Bay. And then what we've got is, they get asked, is this a new station entry that you're deploying, or are you servicing an existing one? And basically the choices that you have available to you change depending on your choices. Yeah. So, if you were to go with a new entry, you get prompted as to whether or not it's a new service group or an existing service group, so on. But if you select that it's an existing station that I'm going to work with, then that changes the workflow that you're following subsequently. So in this case, particularly with gully temperature probes, there was a request that the technicians be able to see what the whirring location actually looked like. So because when they busy setting up the rigging and stuff for the temperature probe, it's nice to be able to get an idea as to where this thing is going to be deployed. So they've often got a site, a photograph of the places that the hobo needs to be deployed. So I added in some functionality where you can upload photos associated with different stations. So this is the photo I currently have associated with Kenton-on-Sea. So it's a hobo that will clearly work for food. And then what happens is when you select the type of the instrument, then all of the previous information associated with that instrument gets pulled from our database and displayed in the app. And then the technicians would be able to just select, change the information that's needed to be changed, and not have to update everything from scratch. But then if there's a new station entry, then it goes through a different workflow. So I'll just go do that. And then it'll ask you to do things like upload a photo. So here it is, using a mobile device in order to capture photos. Or if you've got, oh, come on, machine. Or if you've got them stored in the file system, you'll be able to access it through File Explorer. So that's more or less how that system works. Essentially, what we've got is multiple workflows associated with different types of instruments. So there's let me look at that spreadsheet. It's still open, right? So if you look at the way that the spreadsheet was designed, essentially at each point that you've got, if you're doing a thermistor string, or you're doing an acoustic Doppler current profiler, or whatever, then those questions and types of information that you need to harvest for that are contained within these different groups. So you'll see there's a repeat here for UTRs, and there's another repeat here for gully temperature probes, and so on. And then later down the line, if we want to start capturing new or different information, what you'll be able to do is just simply add these as rows inside here, and then those changes will be reflected within the data table that's online. So on those lines, let's go on to the data table. So apologies, it's just going to take a few seconds. So within ArcGIS Online, each survey that you've designed is stored in a particular folder. So this is the folder that's associated with mooring pre-deployment. And basically, all of the data that gets uploaded from survey 123 gets put onto uploaded onto a central data table that you can then interact with. So if you go to the data tab, you'll see all of the questions that were asked inside the survey. It gets stored here. And then there are different layers. So in this case, if you want to look at the water temperature or thermistor strings, you can see that this is the information that was harvested and updated. So where was I going with this? All right. So that's how it looks in survey in ArcGIS Online, as kind of the landing page. But then from there, what you need to do is you need to start updating all of the kind of related tables and so on that that you've got associated with that particular survey. And the way that we did that is by using Python. So essentially, the way that it works is that the Python script that we've got pulls information from this mooring pre-deployment layer and then goes and writes all the new information that we need to these different data tables that are associated in ArcGIS Online. And some of them you'll see are feature layers, which means that they are associated with mapping activities. And that leads us quite nicely onto the dashboard that I developed for this particular system. So the requirements that the technicians had for the dashboard is that they wanted to be able to see, where the different instruments that they have deployed are located, and how soon do those instruments need to be collected. So, is it because some of them have got a 6-month service period and some of them have got a 3-month service period, or some of them, they're just got to be underwater until the battery runs out. They're different deployment periods, and being able to track that through a single application rather than an Excel spreadsheet is quite helpful. So I built this dashboard with the idea that you've got an overview page, which shows you all of the instruments that are currently uploaded to the OIMS. And then you've got specific tabs associated with different instrument classes. And then over here on the left, what you've got is you've got the navigation page. So if you just click on any of these, it'll take you to the different monitoring sites that they have at present. So if I just click on Marion Island, it'll then pan us to Marion Island or KwaZulu-Natal Bight. There we go. There's the KwaZulu-Natal Bight Sentinel site. Currently, we only have data uploaded for Algoa Bay, so I'm going to focus on that for our demo. And what's quite nice is that this navigation pane is actually linked to all of these tabs. So for instance, you'll see Algoa Bay over here, but then if I go to UTR arrays, you'll still see Algoa Bay if Algoa Bay is selected. So then the next thing that we did is for each of these instrument types, we then had different types of information that we wanted to be able to provide the technicians. So the first most important thing for them was to know, okay, which are the most urgent instruments and which are the least. So for instance, if I go to the CT probes, what you'll see is that actually UTR array is just not a bad example. Yeah, basically the way that it works is that this list is designed to show the technicians, in terms of priority, how many days until a particular instrument needs to be retrieved. So, and then, where is it? How do we deal with this sort of thing logistically? So this list is interactive, and it also it causes things to happen on the map. So if I click on this Kromaloa, you'll see that it automatically pans the user to where that particular instrument is located. And then what it also does is it brings up all of the ancillary metadata that we've chosen to display in a little pop-up over here. And we could actually, this is completely customizable. So you can pull in additional data or display it in a different way, or if you needed a chart, that's a doable thing. And then all items on this list are displayed according to priority. So the least urgent would be at the bottom of the list, and the most urgent would be at the absolute top of the list. And then you can also do stuff like interact with the legend, so you can get an idea as to when these different things are due. So I think that's quite helpful. And then the next thing that we've been working on is looking at scheduling. So one of the big things for these technicians is because they're going out on a boat, weather plays an enormous role in deciding whether or not they'll actually be able to get out to these different instruments in order to service them. So I've been looking at different ways of including weather predictions and forecasts into these dashboards. And we've started engagements with SAEOs to see if there's a way that we can start pulling in SAEOs predictions into these dashboards live. But for now, what I've got is this. It's not working 100% in the dashboard yet because it's not animating, but it should work for demo purposes for us now, said he, holding his thumbs closely. So this is just the radar over time for a particular area. So if I click the play button, we should get the radar for those different regions. So the guys should be able to see, what is a particular front doing in relation to the work that they want to perform. And it's it's nice about this data set is it's a global data set, so you can really see these things coming from a ways. And I need to fiddle with things like the time periods and so on. But this is the kind of direction that I would like us to be able to go with these dashboards, where we can start pulling in ancillary data sets such as weather and warnings to be able to plan operational activities. And what's nice about this stuff is that because it integrates with a number of other systems, we can start doing things kind of similar. I don't know if any of you have ever shared your location with with someone else through WhatsApp or something like that, where you can share a live location. So you can do that with the system as well, where if you've got a live location shared, people will be able to see where you are on the dashboard. And I think that could be quite helpful from a health and safety perspective when people are doing field work in remote places. We often wonder, you've got a storm warning for a particular area. Have they come down from the mountain? You'd be able to see that if we had this sort of stuff used on a regular basis. So yeah, that's the dashboards. Then I'm afraid it's back to death by PowerPoint. My apologies. Okay. So basically what I learned doing this whole thing is that it's not a linear process the way that I had initially thought about this. The way that people interact with data is actually a cyclic thing that's continuously ongoing. So what you need to make sure is that the changes that you make to one system are reflected throughout, but that the history of those changes is maintained and is persistent. So what was really important was to engage directly with the end users for the system and build it so that it's useful for their different use cases. So this one that I've shown you guys now is very niche because it's just pre-deployment of continuous monitoring platforms to specific sites. But we can start to build a like a constellation of different applications that all talk to central databases in ways that are interoperable and allow us to very easily map and present and track and work with the data that we collect. And I realized very quickly that you can't try to build one thing that can do it all. It's just not going to happen. And so through engagements with the technicians, we realized that you can build things that are modular so that you can accommodate changes over time. And linked to that is understanding the operational data cycle. At what points is what type of information important? And linked to that is SOPs. I was very fortunate in that for these instruments that I built the system for, Inti and Co have compiled superb SOPs. So it was very easy for me to see, okay, this is the types of information that they are collecting at what point in the process. And then test, because the number of things that break was surprising. I think I've ironed out most of the bugs for now, but I think I'm getting there. So yeah, then going forwards, what I want to do is start to incorporate better tools for planning and scheduling based on factors such as weather and hazard reporting. And I want to develop the procedures for capturing deployment and post-deployment workflows. And then I also need to work on a system for managing vehicles and vessels and crew and personnel and so on. Because that in itself is also a scheduling issue. And I'd like to engage with the rest of SAEON in order to investigate how we could use what I've developed in order to do things like biodiversity surveys and citizen science. For example, if you had a biodiversity survey and you're doing repeat surveys or something like that, what you might want to do is rather than having to manually capture everything you see, what you could do is set your survey up so that next time you return to a particular area, a lot of those survey lists are pre-populated, and you'd be able to say, okay, no, we didn't see these things, or yes, we did see these things, or these are new things that we saw. And I think that could streamline the way that biodiversity surveys happen quite significantly. And then for citizen science, I think that this is also powerful because you can share these applications that we develop publicly, as well as the dashboards. And the public won't be able to change data that's already in the system, but they'll be able to submit new records and see how those records change over time. And I think that could be really helpful for science engagement and generally for us to work more closely with the communities that we've got. And you can do things like, for instance, you don't have to work in English, and there are systems in on survey 1, 2, 3 to assist with different impairments. So different ways of visualizing things, different ways of interacting with the app to assist blind people, and so on. So you can really work with a broad spectrum of society. And what I'd also like to do is use the lessons that I learned to assist other SAEON nodes and research infrastructures with developing their own operational information management systems. Yeah, so that's me. Does anyone have any questions?
Thanks, Hayden. Super interesting. So I see in the chat, Aubrey made a comment around it's something for the climate and flux working groups to look at. If anyone has any other questions, or Aubrey, if you wanted to discuss anything more, please raise your hand and unmute, and we can have a discussion. So while we wait, Hayden, I actually have a question. What if someone is not familiar with GIS? So they've never used Survey 123, they've never used an ESRI product, they know GIS. How does the system help with sort of non-technical users of GIS systems?
Well, I think that's one of the things that's quite nice about the dashboards, is that because they're designed to kind of be, kind of clickable and interactive. You don't have. I don't think you have to be a GIS user specifically in order to interact with the data. You can build these things to be responsive. So, for instance, if we had weather data, for instance, associated with a point, people could click on that weather station and it brings up a pop-up of observations over time, for instance. I think that the interface associated with Survey 123 is quite helpful, because it also enables people to collect spatial data without being a GIS user. You can stand at a point and click collect, and then you can collect a point, or you could in the instructions inside the app, you could say, say for instance you wanted to map the boundaries for stands of alien invasive species. You could provide people with instructions in the application to say, okay, stand here, click collect, and walk around the thing, and then push done, and it'll automatically upload. So you can really capacitate people that are not technical GIS users through the system. The examples that I've got here are maybe a little bit technical, but the most simple one was something that I developed a while ago for just as a little quick demo. So if you have a look here, this was a little Met Science citizen science thing that I thought of, where you've got basically a few data points saying, okay, add a name and surname, and then please submit the location where you're taking the reading. And if the person were using a mobile app and not a laptop indoors, which has no satellite connectivity, they would be able to click that button and it would just give you a GPS location. And then it brings on to the next section, which is, what type of instrument are you adding? Is it temperature, or is it precipitation? Add a date, add a time, and do you want to upload an image? And then you can click done, and then that citizen scientist has just added their data to one of our databases, which we can then do different types of QA and QC procedures with. And the place that I've been personally very excited about this is for creating training data sets for machine learning. So if we could get people like hikers or rock climbers or mountain bikers to use our application in order to identify the locations of different types of invasive alien plant species, you'd then be able to use these points that they collect in order to train machine learning things, and then produce live maps in dashboards where people would be able to see, okay, there's the point that I collected. These are all the points that everyone else collected, and build a bit of a community around this sort of thing.
Awesome. I see Kogi's already has sent a message on the chat saying that she's looking forward to working on the citizen science. I think that's awesome. We do have a question around how this could help with live disaster management, such as the recent KZN floods.
Sure. So it actually, I don't think they used it recently for the KZN floods, but it was used extensively for the Mozambique floods a few years ago for rolling out disaster and relief efforts. And what was cool about it is that you could identify target areas and then say, okay, where are the people that need assistance? And then, because of the fact that we've got built-in routing algorithms that work within these types of contexts, you'd be able to do quick analyses in order to say, okay, for a field worker, the route that you guys should drive in order to service that area is like so. And then the field worker would be able to navigate to that location using the app, and then on the form, fill it in and say, okay, we're done, and move on to the next one. Actually, and you've just prompted me, one of the things that I found quite funny was, I don't know if any of you saw the tablets that the field workers for the national census were using. Their tablets were all running Survey 123, and so Survey 123 was used for the national census in order to collect all of that household data and location information that we supplied. So that kind of shows you the sort of scale that this thing can operate at.
Super interesting. Aubrey, you have a question?
Yeah, a couple of comments and questions. So yeah, I think the timing of this presentation is fantastic, because obviously there's a lot of work going on with SOPs for the terrestrial nodes as well. And it's a great time to think about how we can set up some of these sort of workflows to record what we do in a more efficient manner. I was wondering if you've given any thought to linking the information that you collect in here to the observations database. And the reason I ask that is because we've in the recent past started thinking about how we link metadata, sort of our operational metadata, to the data sets that we make available through the OpsDB.
Yeah.
So yeah, we've basically got like a set of folders on a repository, one for each station, that we're going to be recording whatever metadata might be of interest to a data user. And I think something like this could feed into that very nicely. Just looking at the presentation, that there's obviously a mix of sort of administrative things that only technicians really need to know about and see, and then there's stuff that might be of interest to actual data users as well.
Yes, absolutely. So one of the I have been chatting to MT and Co around how to integrate the stuff into the ObsDB. To start off with, we were just looking at the kind of lowest hanging fruit use case, which was just get the scheduling system working. But what's nice about this is that if there's ancillary information that needs to be harvested, it's very easy for us to add that sort of thing in. And then it's also equally easy for us to parcel that information into a particular type of data table that gets put somewhere useful. for addition into the OBS-DB. So for instance, in the Python scripts that I've developed, it routinely does things like data subsetting, checking, has this thing changed at all from that? And then you'd be able to quite easily add and track those types of metadata changes over time, and provide that as like almost a view that could be read by the OBS-DB. So yes, we're definitely thinking along those lines, and the idea is to try and reduce the administrative load as much as is possible. So this was the pre-deployment workflow, and I have a suspicion that the OBS-DB stuff would probably come in more with the post-deployment workflow, where the technicians are doing data downloads, and then you might need a system where you're kind of logging, going through the different instrument logs and seeing, okay, was there an error associated with this or something like that. That's definitely going to be dealt with in post-deployment.
Cool.
Great. I think we have one more question. I think we've got time for one more question. So Mark Pinnar, your teammate, has raised his hand. So go ahead, Mark.
Thanks, Hayden. That was a very good talk. It seems like you can add imagery into the forms itself. And I've always thought that it would be useful to have diagrams of the various sensors and whatever else that you're measuring with instructions, like PowerPoint.
Absolutely.
Okay, that was just a comment to think about as well.
Yeah,
okay.
Definitely.
Okay, great.
Yeah, so that's actually why. And you can. It would be really helpful. I mean, you could include wiring diagrams and all sorts of stuff inside there. How to tie the right types of knots. You can even embed videos if you wanted to inside the surveys. So it's not just that the surveys are used for uploading data to the database, but it might be really helpful to provide the users of the mobile device of applications with additional supplementary information. So yeah, I think superb point.
Awesome. Thanks, Hayden, and thanks everyone for the questions. We're in the last minute, so I think I will take the opportunity again to thank everyone for attending. The next presentation is going to be on the 3rd of June, and that's going to be a speaker, Dr. Shirley Parker-Nance, who's just joined the uLwazi team, and she's going to be talking about Belter, the way forward, a new LTER platform on benthic change. But we will send out adverts before the time, and then this will be uploaded to the SAEON YouTube page, which you're welcome to share. Thank you all so much for attending. Cheers. Yeah.